Hello, this is my video lab report for Lab 4 Oscillations. For this lab, I analyzed a given video with oscillating motion in both the x and y directions in order to learn more about the energy principle and oscillating motion in general. To begin, there are quite a few important ideas that need to be understood in order to move forward in this lab. These include Newton's second law, the energy principle, kinetic energy, gravitational potential energy, spring potential energy, force due to gravity, and the spring force. The formulas written out are shown on screen now and will be vitally important in the modeling process in GlowScript. The first change I made to the code was adding in the given mass of the object and changing the initial position and velocity vectors to reflect my findings from Tracker. After using position and time values, I was able to calculate both the spring constant and the relaxed length. Using all of the knowledge regarding the experiment and values thus far, I set up further variables to be used later in iterations such as L hat, kinetic energy, gravitational potential energy, spring potential energy, and total energy. I then moved on to my iteration loop, which I set to run up until the point of my last observation experimentally, which turned out to be 9.402 seconds. Using all of the variables from above, I set up multiple equations which would update various values for my model throughout the loop. Most notably, these equations continuously update the position and velocity of the object and also show the changes in energy. Before being able to run my code, I needed to extract the x and y position values from Tracker, which were found by analyzing the video shown here. After transferring these values into a spreadsheet, I converted it to a .csv file, which I then could upload to GlowScript in order to get a working model. The resulting model after I let it run can be seen here on the left. More importantly, the energy versus time graph is plotted on the right. I will come back to that in just a minute to discuss its significance and implications. First, these are my x position versus time and y position versus time graphs on the top and bottom, respectively. For the x position, there is a discrepancy when comparing my model to my experimental observation throughout the whole graph. However, for the y position, the lines really only begin to deviate significantly from each other near the end. The major source of error here is that I could have simply messed up when using the point mass feature on Tracker and gotten inaccurate position data. My calibration stick could also have been placed somewhat incorrectly, accounting for some of the error. There is one more source of error, but I'll get back to that in a minute. Looking back on the graph, which plots energy versus time, a major question must be considered. Does my model satisfy the energy principle? If you remember, the energy principle states that the change in energy is equal to the work, which is ultimately equal to zero. With the gravitational and spring energies essentially being opposites of each other, which makes sense due to compression and stretching, and the kinetic energy seemingly canceling itself out over time, the overall change in energy does look to be zero. Though the orange line does look like it may very slightly deviate from the axis at a couple of points, I would consider it to be close enough to satisfy the energy principle. When taking a look at my tracker data and taking the average oscillation time periods for each direction, I found an interesting problem. The average oscillation period for the x position was quite different from the y position. Because I used only one of these values in my calculation for the spring constant instead of calculating them a different way, this could be another major source of error. Due to this, essentially every calculation done in my code with regards to springs led to slightly incorrect data.